Good afternoon, gentlemen. Welcome to today's presentation, which is going to be an introduction to electronic fuel injection, EFI. So I'll start by handing you out a handout. This is your resource for the training. So while we're actually going through the training, if you follow it with your PowerPoint handout, you'll see that there's a spot there that you can make some of your own notes. I'll write down any questions you might have for the end. Okay, just before we start, we'll just go through some housekeeping. Toilets are through the workshop to the end and over to the right. If we do have an emergency, I must have pointed out the front of the building. I do have a class register, so we'll leave the building in orderly fashion and then I'll take the register in the muster point. Okay? All right, gentlemen, we'll make a start. So, as I said, today's presentation is Introduction to Petrol Electronic Fuel Injection, EFI. Okay, so the learning outcomes for today are to identify the types of EFI systems, okay, learn about some of the components that are present with EFI, and also we're going to talk a little bit about the air intake system and the electronic control of electronic fuel injection. Okay, so as I mentioned in resources, you've got your handout in front of you, which I've given you, and also all of the PowerPoint presentation information has been taken out of the EdMay Automotive Mechanics Volume 1. Okay, so let's make a start. Okay, as an introduction, there are two different types of petrol fuel injection. We've got mechanical fuel injection, MFI, and we've got electronic fuel injection, EFI. So we're going to concentrate on the more modern EFI, the electronic fuel injection. Okay, there are other types of fuel systems that are used on vehicles, for example gas, and also we use a diesel fuel as well. They're just some alternatives, but today we're just going to concentrate on EFI. Okay, the idea of this type of fuel system is to provide the fuel to the engine in a form in which it can be burnt. Okay, there are subsystems to EFI where we've got to control air supply. We've got inputs to the ECU, and the ECU is actually used to control the fuel going into the engine. Okay, so if you look up onto the board now, can you see that clearly? What we've got here is a schematic of a basic EFI system and some of the components that we've got in there. So if we have a look over here, we've got our fuel tank there, so that's our supply. Okay, we've got fuel filters in the system, we've got a fuel rail, we've got a means to control the fuel pressure in the fuel rail with a pressure regulator, which we'll talk about shortly. We've got a throttle body, we've got an air cleaner assembly, and we've got our electronic injector there that's actually directed into the port. Okay, and what controls the whole thing is the ECU, the electronic control unit. Okay, so types of EFI systems. Now I mentioned that we've got two types of fuel injection. We've got mechanical or we've got electronic. Well, even with the electronic, we have two variations of that. Firstly, we had what we call center point fuel injection, where we're only using a central location to inject the fuel, which was then distributed to all of the cylinders. As we moved on, okay, we went to what we call multi-point fuel injection, where we had a fuel injector for each cylinder. The very first one, the center fuel injection, actually used to look very much like a carburetor when you take the air cleaner off, because it was basically a carburetor body with two injectors in the top of it. Okay, so the inlet manifold was a similar design to a vehicle that did have a carburetor. Okay, the picture that we've got up on the board is showing a multi-point injection. How do you think we can tell straight away just by looking at that picture it is actually a multi-point? Because we can only see one injector there, can't we? But it's the location of the injector that's the critical factor. It's actually going into the port. All right, some of the components that are in the system, we've obviously, as I mentioned before, we've got the fuel tank. Then we've got to have means of providing fuel pressure, okay, because these fuel systems don't work like a carburetor, we have to have fuel pressure. Okay, so we've got a fuel pump, and then we've got a fuel filter in the system. The fuel filter's there obviously to remove any contaminants that are in the fuel before they get to the fuel rail. And we've got the fuel rail, which is actually the supply point for the injectors. Okay, we've got the injectors themselves, which are electric and electronically controlled by the ECU. We've got a pressure regulator on the fuel rail to maintain a particular pressure that we want within the fuel system. Okay, and we've got a return line that takes fuel back to the tank from the fuel rail, from the bottom of the fuel regulator. Okay, some of the other components we've got is an air cleaner assembly, which is not dissimilar to just a normal carburetor or a centre point. And we've got a throttle body to control the amount of air that actually goes into the engine. Okay, as well as allowing air to go into the engine, we've got to know how much air is going in. So we have to have a means to measure the volume of air that's going into the inlet manifold. We also have a device called a plenum chamber. This is a large area of volume built into the inlet manifold, which dampens out any pulsations, okay, and provides a large volume area, so there's enough air there for whatever cylinders actually want it or need it. And that's all combined with an inlet manifold, and then at the bottom of the inlet manifold we've got an injector in every single port. Okay, electronic control. We have to control these injectors, and we do this with a device called an ECU. The device will command the injectors to operate as they're required, but to do that, the ECU has got to have some inputs from the engine. Some of the things that I've just mentioned to you. Okay, so we've got inputs like our crank angle sensor, we've got inputs like our MAT sensor or our mass sensor. Okay, all of this information is inputs to the ECU, so the ECU can calculate the correct amount of fuel that is injected by the injectors. Any questions so far? Okay, so each injector is operated individually and depending on throttle position. So if we open the throttle up, then obviously we're going to want more fuel in there, aren't we? Okay, we'll look at the fuel pump itself, because unlike the carburetor engines, we have to use a much higher fuel pressure. Okay, and we also have to be able to control that fuel pressure. So there's varying different types of fuel pumps that we use. We can have fuel pumps that are actually inside the fuel tank, that are incorporated into a fuel pump module assembly, or we can have the fuel pump external from the fuel tank. Okay, there are just two different designs. More commonly now, we actually have the fuel pump built into the fuel pump module assembly, and it's actually internal in the fuel tank. Okay, so we've got the, once the fuel pump runs, we're going to develop pressure in the fuel system. Okay, that pressure then is directed directly to the fuel rail on the engine. Okay, so pressure is going to start to build up in the fuel rail, but we only want the pressure to reach a certain amount. Okay, so at some point we've got to relieve that pressure in the fuel rail. Okay, and we return that fuel pressure to the tank. Now, the way the regulator works is, as the pressure increases in the fuel rail, the regulator has got a spring and diaphragm built into it, and once the pressure reaches a certain point and overcomes the weight of the spring, okay, the valve can open and then return fuel to the tank. In doing so, it drops or maintains the fuel pressure in the rail. Okay, so going back to the ECU, once we've got an available amount of fuel pressure in the rail, we can then obviously operate the injectors to release some of that pressure from the rail through the injectors and into the engine, into the combustion chamber. Okay, the main function of the electronic control unit is to tell the injectors how long they should be open, depending upon the inputs that the ECU is getting from the engine. Okay, so obviously they're always changing all the time, depending on throttle position, engine speed and engine load. So I said the ECU receives the signals from the various sensors. It then processes that information and then controls the operation of the injectors. We're going to have a look a little bit further into the fuel pump. This type of fuel pump that we've got now, or shown on the picture there, is an external fuel pump. Okay, so that would be mounted outside the fuel tank. It's what we've known as a rotary pump. That's a Bosch type pump. Okay, now that type of pump relies on fuel for cooling and for lubrication. So these type of pumps can't be run with no fuel going through it, because you will actually damage the pump. Okay, so we need high pressure to charge the fuel rail, but these pumps are capable of delivering an awful lot more pressure than what we actually require. So there's a couple of things that we need to look at with the electric pump. Firstly, that it's got an internal pressure relief valve, which is this device here. Okay, so when the internal pressure reaches a certain amount, a predetermined amount, it'll overcome the spring tension, push the ball and relieve the pump, so the pump can't produce excessive amounts of pressure. Also, on the front of the pump, if you look there, we've got another type of check valve. So that is actually a one-way valve. What do you think the purpose of that would be? Hayden?
So fuel can only go in one way?
No, well, fuel's going to go in one direction, isn't it? Yeah. And it's going to charge the fuel rail. But then, if we were to turn the fuel pump off, for example, and we didn't have any type of check valve there, what do you think could possibly happen? Any ideas? No, we've turned the fuel pump off now. So imagine that we've driven the vehicle and we've come to a stop, we've turned the car off, and then later on we want to go back to it and start it again.
Oh, no pressure in the line.
Exactly, there wouldn't be any pressure in the fuel line. So the idea of having a check valve in the fuel pump like that is to maintain system fuel pressure. So the next time that we come to start the vehicle, okay, the pressure in the fuel rail is already there, so there's not going to be any delay. I don't know if you've ever noticed when you change the fuel filter and you reconnect the system up, and then you go to crank the vehicle, it takes a little while for the pressure to fill, because it's got to fill the lines or fill the filter and charge the rail. Yeah. So that small device there just prevents that from occurring.
How come they put such big, you got there, but it's capable of producing up to 600 kVA. How come they put such a, why do you put such a fuel pump like that on if you only need like 200 kVA, so much pressure?
Okay, that's fair enough. Well, it's going to provide enough, no matter what is demanded of it. It's okay. It may be a bit of overkill. Yeah. Okay, but that's going to make the pump work not flat out all the time. If we're going to put a pump in there that can only produce 200 kPa, okay, then it's going to be working at its maximum all the time, isn't it? Yeah. So what we've done is we've actually got a pump that can deliver far more than actually needed, but we've got an internal pressure relief valve in the pump, so it can't overwork or
so it doesn't burn out.
Yeah, it's going to improve the life of the pump, isn't it?
Yeah, right.
Okay, so the pump is always full of fuel, which, like I said, both lubricates and it cools the pump or the motor when it's turning. Okay, so you can't run these pumps with no fuel going through them, they won't last a very long time. They do get quite hot, so the fuel running through them will take that heat away. We've talked about the non-return valve and the fact that actually works when we turn the car off. And we've also talked about the relief valve that's internal with the pump. You can't get to that, or you actually, these type of pumps, you can't take them apart at all. They're all crimped together and sealed. Okay, so we'll go back to, or just finish off with looking at some of the sensors that are involved in the EFI system. So we've got all our input sensors, and then we've got outputs. So our inputs are information going to the ECU, and outputs are commands that the ECU is making to make alterations, either increase or decrease the duty cycle of fuel injectors or alter ignition timing. Okay, so we'll summarise on what we've talked about. So EFI is an electronic system that provides high pressure fuel in a programmed precise manner. So what's some of the advantages of that, do you think? What's some of the advantage of having a much better control over how we deliver fuel to a vehicle?
Emissions.
Okay, so we're going to get a reduction in emissions. Okay, and what other advantages do you think we could have?
You have more power, wouldn't you?
You can, yeah, you certainly can have more power, and probably another one.
Timing.
No, it's not.
Fuel economy?
Fuel economy, yeah. We're going to get better fuel economy, we can get power output, and we can also reduce vehicle emissions, which is usually the main thing that drives us developing and making things better, so we can reduce emission all the time. Obviously, if we're going to get better fuel economy, then we're using less fuel, so we're creating less emissions. Okay, so EFI systems of what we've got on vehicles today are they're very there's no adjustments to be made anymore. Okay, so servicing, we've even removed fuel filters now. We've got in-tank filters directly built into the fuel pump module assembly, so we don't even have a filter under the car to change it anymore. So apart from doing self-tests, if we've got fault codes, there really isn't anything that we actually need to service on them anymore. Okay, so that's another advantage. And we get it provides a reliable, constant fuel delivery. Okay guys, so what I'm going to get you to do now, I've got a short test, okay, a few questions about what we've covered today, and then once we've completed that, I've got a short survey for you to fill out. You don't have to put your name on this one, okay, unless you want to, but please take your time in filling it out, because the information that I get back from the survey is used to improve the training at a later date. I'll give you a few minutes to go through that. There's a few questions there. Like I say, you don't have to put your name on. Just hold them up, guys, when you complete, and I'll just come round and collect them. Thank you. Thank you. So, I'll just wait for Elijah to finish. So what I've decided, rather than do some written questions today, I'm going to just verbally ask you some questions and see how much of the information you retain. Okay, so first off, I was talking about different types of fuel systems or fuel injection systems. Aidan, what were the two different types of fuel injection, petrol fuel injection?
Mechanical and electrical?
That's right, yeah, we've got the mechanical. That was an early system, and it was one that was pioneered by Bosch, okay, but we didn't have the sort of control over the fuel system like we do with electronic, because all of the injectors would fire simultaneously. So that system didn't stay around for very long, and we moved on to the electronic system. Okay, Elijah, in regards to fuel pressure, how's it developed on an EFI system? Where do we get our fuel pressure from?
Fuel pressure is normally from the pump pumping it out of the tank.
Yep.
Or it can be maintained on the fuel rail with a external pressure reg or a reg built into the rail.
Okay, so we've got a fuel pressure regulator on the rail, that's correct. So we'll build fuel pressure up as soon as we turn the pump on, but then to maintain the correct pressure in the fuel rail, we've got to control that by means of a regulator, okay, which is a mechanical device that's got a spring inside it, and that's set at a particular tension. So as the fuel pressure starts to build, it will start to overcome the spring tension of the spring and then allow fuel to go back to the tank on the return line, so maintaining the fuel pressure. Okay, in regards to controlling the fuel, how much fuel the injectors will actually deliver to the engine, what are some of the devices on the engine that can, that would be an input to the ECU in regards to that? Throttle position is an input, yeah. Any more? Yeah, like I mentioned, we've actually got obviously we open the throttle and we allow air to go into the engine, but we need to know how much is going in so we can maintain what? The correct air fuel ratio, that's correct, yeah. What were some of the earlier electronic fuel injection systems that I mentioned right at the start, the earlier electronic fuel injection systems where it wasn't multi-point? Remember we had the device that looked like the centre point, that's right, we had a device that looks like a carburetor. There's not many of those around anymore. We didn't stay with centre point for too long. Okay, and what maintains, when we turn the vehicle off after we've ended the journey, what maintains the fuel pressure in the systems to aid starting the next time? Cameron?
The valve.
The non-return valve, that's exactly right, that maintains the fuel pressure in the system. Okay gentlemen, is there any questions on what we've talked about today? Anybody? Okay, if there's no questions, I've collected in your surveys. Thank you again for your participation today. Thank you very much.